The universe as we know it is a paradox of elegance and chaos, a vast expanse governed by the intricate dance of physical laws. But as the cosmos ages, these laws begin to behave in ways that defy human intuition. Physicists have long debated the ultimate fate of the universe, with theories ranging from the poetic to the downright bizarre. However, what remains constant is the unsettling truth. As we approach the universe's end, physics starts to act in ways we can barely comprehend. Let's begin with the one force that rules the universe in ways we only partially understand. Gravity. Gravity, the glue of the cosmos, holds everything together from the planets in our solar system to the stars in distant galaxies. For most of history, we assumed that gravity would dictate the universe's destiny, either pulling everything back into a fiery collapse, a big crunch, or holding everything in a delicate balance. But at the turn of the 20th century, astronomers made a startling discovery. The expansion of the universe wasn't slowing down, it was speeding up. This revelation was tied to a mysterious phenomenon called dark energy. Think of dark energy as a cosmic accelerator, pushing galaxies apart at an ever-increasing rate. While we've given it a name, we have no idea what dark energy truly is. Some believe it's the energy of empty space, while others theorize it's a new field of physics we haven't discovered yet. Either way, its implications are profound, because the ultimate fate of the universe depends on its nature. If dark energy is a stable property of the vacuum, essentially, the energy of nothingness, the universe will continue to expand forever. This is the scenario physicists call the Big Freeze. Over billions of years, galaxies will drift further apart until they are no longer visible from one another. Stars will exhaust their nuclear fuel, planets will freeze, and black holes will slowly evaporate. Eventually, all that will remain is a cold, dark void where nothing ever happens, a state of maximum entropy where time itself loses meaning. This idea of a heat death is terrifying not because of its violence but because of its absolute finality. In this state, the universe reaches thermodynamic equilibrium, meaning no energy is left to do work. It's the ultimate stillness, where the very fabric of time and space ceases to have relevance. But what if dark energy isn't stable? What if it changes over time? This introduces an even more chilling scenario, the Big Rip. In this model, dark energy doesn't just push galaxies apart. Its intensity grows over time, becoming so powerful that it tears everything apart: galaxies, stars, planets, and even atoms. Imagine the force that keeps protons and neutrons together being overpowered, leading to the disintegration of all matter. The Big Rip is physics at its most unsettling, as it predicts a universe not only dying but violently shredding itself to pieces in its final moments. Another bizarre possibility is the Big Crunch, which stands in stark contrast to the other theories. Instead of the universe expanding forever, what if gravity wins in the end? In this model, the universe's expansion slows and reverses, pulling galaxies, stars, and all matter back into a single, infinitely dense point of singularity. While this might seem catastrophic, some physicists speculate it could be the precursor to a new universe. The Big Crunch could lead to a big bounce, where the collapse of one universe seeds the creation of another. If this is true, the universe may be trapped in an eternal cycle of birth and rebirth, each iteration potentially different from the last. Beyond these large-scale theories, the end of the universe also presents a stage where the fundamental forces of physics start to unravel. Consider black holes, for instance, regions of space where gravity is so strong that not even light can escape. Black holes are already enigmatic, but as the universe evolves, their role becomes even stranger. Over unimaginably long timescales, black holes will slowly lose mass through a process called Hawking radiation. This phenomenon, predicted by Stephen Hawking, suggests that black holes emit tiny amounts of energy and eventually evaporate entirely. But Hawking radiation raises troubling questions about the nature of information. According to the laws of quantum mechanics, information about a system can never be lost. Yet, when a black hole evaporates, it seemingly destroys all the information it contained, violating this fundamental principle. This conundrum, known as the black hole information paradox, has led physicists to question our understanding of reality itself. Some propose that information is stored in the event horizon of a black hole, while others suggest it might be encoded in the very fabric of spacetime. As black holes fade into nothingness, what remains of the universe enters a phase called the dark era. In this epoch, ordinary matter is almost entirely gone, leaving only subatomic particles and faint radiation. At this point, even the quantum fields that underpin reality may begin to decay. Some theories suggest that protons, the building blocks of atoms, are not stable and will eventually disintegrate into smaller particles. If true, this means that all matter down to its most basic components will cease to exist. Adding another layer of existential dread is the concept of vacuum decay. Physicists theorize that our universe exists in a false vacuum, a temporary state of stability that could one day collapse into a more stable, true vacuum. If this happens, it would create a bubble of true vacuum that expands at the speed of light, obliterating everything in its path. The terrifying part, we wouldn't see it coming. The bubble would annihilate particles, atoms, and even the laws of physics themselves, replacing them with an entirely new reality, one where life, as we know it, could never exist. Yet, for all its bleakness, the end of the universe also inspires awe. It forces us to confront our place in the cosmos and the limitations of human understanding. Physics, as advanced as it is, might only be scratching the surface of deeper, more complex truths about existence. Concepts like the multiverse, collection of parallel universes, offer tantalizing possibilities. If our universe is just one of many, then its end might be insignificant in the grand scheme of things. Other universes might flourish even as ours fades away, and new ones might be born from the ashes of our cosmic demise. The study of the universe's ultimate fate also pushes the boundaries of philosophy and spirituality. Why does the universe exist at all? Is there a purpose to its apparent impermanence? While science focuses on empirical evidence, these questions invite deeper contemplation about the nature of reality and humanity's role in it. In contemplating the end, we also gain a greater appreciation for the present. The universe, in its current form, is a fleeting miracle, a delicate balance of forces that allows life to exist. Stars shine, planets orbit, and on at least one tiny blue planet, sentient beings ponder the mysteries of existence. This fleeting moment in cosmic history is precious precisely because it is temporary. The unsettling nature of the universe's end is a reminder of the limits of human understanding. The laws of physics, as consistent as they seem, may break down in ways we cannot yet fathom. The end of the universe is not just a scientific question, but an invitation to explore the very foundations of reality. Whether it ends in a big freeze, a big rip, a big crunch, or something entirely unexpected, the universe's demise underscores one profound truth: existence itself is both fragile and extraordinary. As we gaze up at the stars and wonder about their fate, we are participating in a timeless dialogue with the cosmos. The universe's end may be inevitable, but the human quest to understand it is infinite. In that pursuit lies not just fear but also wonder, a testament to our unyielding curiosity in the face of the unknown. So, if you enjoyed this journey through the cosmos, don't forget to give us a thumbs up and share this video with fellow space enthusiasts. Your support helps us continue exploring the wonders of the universe. Be sure to subscribe to SPACEEFIED and hit that bell icon so you never miss an update on our latest discoveries. Dive deeper into the mysteries of space by checking out our other videos, and let's keep the adventure going on together.